Hello, my lovely viewers and my dear students. Welcome back to my math distance learning session. So today we are going to be doing an extension of our last video for grade 9 and grade 10. So this is part 2 of the same lesson. And today in this session we are going to be learning about surface area of cones. So let's get started. So for today's lesson, surface area of cones, the learning objectives are as follows. Number 1, we are going to be relating the concept of cones to real life. And number 2, we are going to be finding the lateral areas and total surface areas of cones. This is a very useful topic for grade 9 and 10. So I would request you to watch the video till the end and answer the question that you see in the last slides. Okay, so look at these examples of cone in real life. What examples do you observe? So in real life, you would see that the ice cream cone, the traffic cone, or your birthday hat, these are all examples of cones in real life. So this is a topic which is very related to our everyday life, a very interesting topic. So let's see more about cones in the slide to come. And if you can think of more examples of cone in real life, do comment and let me know. Okay, so let me introduce to the concept of cones and we begin with the definition. So we are going to be understanding the definition of a cone with the help of this image that you see here. So as you see that cones are in the shape of right pyramids, but the difference here is that they have a circular base. So if I may just highlight the base of this cone. So with this red ink, I have done a freehand drawing of the base. So this resembles the shape of a circle as you see. So cone is a special type of right pyramid where the base is a circle. Now you can find the lateral surface area or the total surface area of the cone using the formula that we had done earlier in the previous video for pyramids, since it is a special type of pyramid. So the formula is going to come down to lateral surface area of a cone is given by pi RL, where R is the radius of the base or the radius of circle you could say, which is the base here. Then your L is going to be slant height. When we had done the video on pyramid, in that lesson I had explained very nicely what is slant height. We had done so many other terms also related to a pyramid. So in case you want to revise that, I would request you to go back to the previous video. I will put the link in the description box and do watch the video on pyramids before you come and understand this video on cones. Okay, so if R, L and H, these three variables are given to you, then you can easily find the lateral area or the total surface area of a cone. So the lateral surface area is pi RL, pi is 3.14, you all know it's a constant, and total surface area can be given by adding the lateral surface area and the area of the base. Now here the base, as we just saw, is a circle. So the area of the base, which is your capital B, is going to be pi r square, the area of the circle basically. So that is what we substitute and we get the total surface area as B plus LA, which is pi r times r plus L. So we've taken the pi r, which is common outside. So that is all about the introduction to cones, and we are going to be looking at some examples in the following slides to see how we can find these two areas for a cone. So when you come to the first important key concept for this lesson, then I'm going to be giving you these two formulas. So let's summarize, and I'm putting them in stars. That tells you these are really important. You need to learn and remember them so that you can solve problems based on cones using these two formula. So again, just to recap and revise this for you, the formula that will help you to find the lateral surface area is going to be pi r L, and the formula that will help you to find the total surface area is going to be The lateral surface area plus area of base, which is pi r L plus pi r square. Remember, your r is going to be the radius of the base or the radius of the circle, L is your slant height, and h is the height of the cone. Okay, so let's take the first example on cones. I will read the question for you. A conical birthday hat has an altitude of 6 inches and a diameter of 4 inches. Find the lateral area of the birthday hat. Okay, so let's see what is given to us and let us highlight the important things which are mentioned. So definitely, as you see in the image, the shape is a cone, okay, and the altitude or the height of the cone is given to you, that is 6 inches. Also, you are given the diameter, that is 4 inches. So from there, you will easily get the radius. And what we need to find? We need the lateral area of the birthday hat. Okay, so let's write the solution now. So given h is going to be 6 inches. That's one thing. D, which is your diameter, is 4 inches. So from there you get the radius as 4 divided by 2, which is 2 inches. Okay. And we need to find the lateral surface area of cone. So let me write the formula, pi r L. Now pi we all know is 3.14. Radius you have got as 2 inches. So the only thing that you need now in this question to get your lateral surface area, which is not given, is L. So if we get our value of L, we'll be very easily able to substitute in the formula and get to our answer. Now to find this L, we definitely have to use the two important information which are given here. That is the value of your H and the value of your R. So let's see how we are going to be using it. In order to use these two information and to calculate the L, I'm drawing here another figure for you. So let me name it as triangle ABC. Now, if your AB is the height of the cone, I can write it with this notation H. This is the base of the cone, so it is going to be having radius R, and L is the slant height that we need to see. And remember, it is a right cone, so definitely this angle is going to be 90. Okay then, so when we see a right triangle, the first thing you should be remembering or recalling should be your Pythagoras theorem. So let's apply the Pythagoras theorem because that is very going to be helpful in this question to get our slant height L. So let's substitute. H is given to you as 6, R is given as 2. So that means this is going to give you L square as 40 or L as square root of 40. So you can do this calculation and you're going to be getting your L as the value of L is going to be around 6.32 inches. Okay, so we have our L now. Let's find lateral surface area. So 3.14. I'm now just substituting the values here. Multiplied with 2, multiplied with 6.32. And I want you to take a few minutes and do this calculation. And remember, when you're going to multiply all this, the unit eventually would come out to be inches square. So what did you get? I'm sure you have got 39.7. This is a decimal coming to round off of one decimal place. So yes, that is our correct answer. So we have got the lateral area of the birthday hat. So that completes your example 1. Okay, so let's do example 2 now. A sugar cone has an altitude of 8 inches and a diameter of 2.5 inches. So here in this question, you can see the ice cream cone and we need to find here using the altitude and the diameter which are given to you the lateral area of this cone. And it's also mentioned here that you need to round it off to the nearest tens. So up to one decimal place, we are going to be rounding off our solution. Okay, so let's write what's given, and then we'll see how we need to solve the question in order to find the lateral area. So given your h is 8 inches, your diameter is 2.5 inches, so that would give your radius as 1.25, and the unit is same, inches here. Okay, now we need to get our LSA, which is pi RL, and here again we are just given the radius and not the slant height. We are going to be doing exactly the same thing we did in the previous question. So you will draw a right triangle, mark the angle as 90. L is what you need, that's not given. Height is 8 and the radius is 1.25. So again, we are going to be applying Pythagoras theorem here, and I'm quite confident that you are able to see the importance of this theorem for cones. So everywhere where you need to get the slant height, you are applying the same theorem. So this is some calculation. I want you to be solving it and giving me the value of L. If you want, you can pause the video and solve the question at your own pace so that you may do your calculations correctly. And I'm sure that you are getting the same value, that is L square, as 65.5625. But what we need here, we need the square root, we need L. So let's do that. L is the square root, and also remember, once you take the square root, you also need to round it off to nearest tens. So this will come out to be 8.097 inches, and maybe we can round this off so that it becomes a little easier for us. So we'll round it off to one decimal place as 8.1 inches. Okay, so we've got our L now. We just need to do the substitution, and that would give us our final answer. Let's do the final step for LSA. So I'm substituting for pi 3.14, for radius 1.25 inches, and for L 8.1 inches. So the unit will here, after the multiplication happens, come out to be inches square. So this is coming approximately 31.7925 inches square on my calculator, but we need to round it off to one decimal place. So I'm going to be doing that and giving my answer as approximately 31.8 inches square, and that is the correct answer. That completes example 2 as well, and I'm sure by now you are getting more comfortable with cones and finding the lateral surface area. Example 3, and in this question now you are going to see that in the same question we are finding both the things, the lateral area and the total area. So let me highlight for you. This is the first thing you need to find, and this is the second thing you need to find. And obviously, if you have got now comfortable with cones and you are feeling confident, then you will recall and you will remember that these are the two formulas that we are going to be using to get LA and SA. Now in the question you were just given the height of the cone, which is 8, and the radius, which is 6. And as you did in the last two examples, you got your L using Pythagoras theorem. So you will simplify this and your L would come out to be 10 units. So here the unit is given in centimeters, so L is also going to be 10 centimeters. Now that you've got your L using Pythagoras, you can directly substitute for LA. That will give you pi times 6 times 10. Now sometimes in the question you don't have to substitute pi. Maybe you are given a multiple choice where the options are in terms of pi. So in that case, you could leave your answer at this step. So 60 pi square centimeter, that's your lateral area. Moving on, let's write the total surface area now. So that is going to be computed by the formula pi r times r plus L. We are just simply substituting r as 6, L as 10 here, and simplifying by multiplying and getting our total surface area, as you see here, 96 pi square centimeter. And remember, this is again in terms of pi. So that completes the last example for today, example 3. Let me now give you some questions to try yourself to test your understanding. Okay, so here I have taken in this slide 2 questions from your math book, from the textbook. So these are your guided practice. I want you to try these questions and solve them in your notebook. So 5A question is going to be your classwork that we'll do just now. And 5B is your homework which you will try yourself and then put your solutions in the comment box. So let's read the question now. Find the surface area of each cone and round it to the nearest tens. So if you see this question carefully, it's not mentioned which area you need to find, and generally whenever it just says find the surface area, that means you have to find the total surface area. Now for the 5A question, we are going to be actually finding both the areas. First we'll find the lateral surface area and then we'll find the total surface area. And the reason is because as you have observed that in the formula for total surface area, we're actually using the lateral surface area. So let's begin the solution. So two things are given to you here which I've highlighted. One is the radius of the cone, which is 0.8 millimeter. Observe the unit. And you are directly given here the slant height L as 2.2 millimeters. So this question is pretty easy in the sense that you did not have any need to go to Pythagoras theorem because slant height is already given. So let's just do the substitution here. So lateral surface area pi RL. So we are going to be substituting the value of pi, the value of L, and the value of L. So just pure computation, you just have to do the multiplication. Make sure you're doing your calculations correctly so that there is no mistake. And the unit will be coming out to be millimeter square. Please don't forget the unit. In a question like this, unit is very important whenever we are doing geometry or surface area. Now we have got the answer for lateral surface area, and before we move to total surface area, let me remind you, you need to round to the nearest tens. So that means one decimal place. So let's round it off. So here for rounding for one decimal place, we will just write 5.52 because this digit is less. So we will just round it off to this decimal place, or if you want, you can just put a 0 here. So yes, 5.50. That's your lateral surface area. Let's do the total surface area now. And as you know, for that, you take your lateral surface area and you add pi r square. So the same formula, pi rl plus pi r square. So I'm just taking up the lateral surface area from here and substituting. I'm taking this value because I'm going to round off total surface area to one decimal place towards the end after I've added them both. So I'm choosing 5.5264 millimeter square. That was your lateral surface area. And let me now substitute for the second term. Radius is given the same value, 0.8 millimeter square. So that would come out to be, if you do your calculations correctly, as 2.0096 millimeter square. Now we are just going to be adding them. They have, each of them have 4 decimal places, so addition is not difficult. It will give you 7.536 millimeter square. Now comes the rounding off, so this is going to be approximately equal to, because it's an approximation, not an exact value, so that's why I'm changing the symbol here. It is no more equal to, it is the symbol of approximation, and let's round it off to one decimal place. Again, it will be 7.50 millimeter square. That completes the classwork question 5A from the guided practice, your textbook. Do try 5B as your homework and then put your answers in the comment section. So with that, we have completed our learning objective for today. We have learned in the lesson today how to find the lateral area and the total surface area of cone. So just to recap and summarize the two important formula. So lateral surface area pi r L, total surface area pi r L plus pi r square. I've put here stars that tells you that you need to remember this formula. It's quite important as you see, so that you will be correctly using them for solving questions on surface area of cones. That brings us to the last slide for today. Thank you so much, my dear viewers and students, for being with me and joining my session. Let me remind you to revise today's session and solve the question that have been given to you for trying. Don't forget to like, share and subscribe to my channel for more math videos, and see you in the next session. Bye students.